Module 11, we will continue to talk about vector from chapter 7. So the vectors came from STL library. Before that, let's talk about searching and sorting from chapter 8. So then we can moving forward to see how to do the searching and sorting from vector. And next week, we will complete the chapter 7 and talk about multiple dimensional array. So that's a little bit move to chapter 8 for now. In chapter 8, we will introduce searching and sorting. This is very important because sometimes when we want to searching for the specific value, we are searching either from array or from vector. So that's why we introduce searching and sorting algorithm after we talk about array. So that will be from our textbook in chapter 8. So in this Monday lecture, we will focus on searching and sorting. So the first thing I will talk about the linear search algorithm. After you understand that, we will talk about sorting to make our array in ascending order or descending order. So the first thing, let's talk about what is search. So since you talk about search, you know you need to have a value you want to search for. So that's why when we do the search, we are trying to locate it a specific item. So this item will be the value we are looking for from a list of the information. So of course, you can see you're looking for an item from a list of the information. In the data structure point of view, we talked about array last week. So the first thing when we talk about searching, we want to searching a value to see if this value exists in the array. So we have two different ways to do the searching. In this class, we only focus on the linear search. So the linear search is searching for a value from. When we talk about linear search, is we try to search a data from a random data order. But the binary search is specific from a sorted data order. So in this class, we only focus on the linear search. So when we do the linear search, we just assume the data actually is not in a specific order, not ascending order, not descending order. We just random do the search. Then in the next class, that will be the COMSC110. In our advanced C++ class, we will talk about the binary search. So when you do the binary search, you need to make sure your data are in the sorted order. So on the other hand, your array need to be in the sorted order before you do the searching. So that's focus on our linear search. So like we say, the linear search is we call the sequential search. The reason is because we don't know if our data in a specific order. So that's why when we want to search for a match data, we need to start from the first element one by one to compare the element with our searching value. So that's why we call the sequential search. You need to start at the first element. So this algorithm sequentially step through an array to examine each element if they are the same as our searching value until we find the match, or at the end of the for loop, we didn't find the value. So that's why here we always start from the beginning to the end. So that's why we call that the sequential search. So the sequential search is like this. As you know, we talk about array, right? If we have array called num list, this array data type is integer. So that's why you see we have the number one by one. They are not the value in a specific order. So that's why we call they are random value. So if, for example, I want to searching for value 11, I want you to think about Even you are human, you will just look at this value or say, oh, 11 is here. But one thing is, sometimes our brain to try to work on find the searching. You feel like you just find the 11, right? But step by step is our eyes look at 17, not 11, 23, not 11, 5, not 11. Then we find 11 is 11. So that's why sometimes you, as a human, you work so fast. You just feel like you right away find the 11. But on the other hand, when you step by step to work on that, you start from the beginning to find that. So on the other hand, so when we want to search for the specific value, when we want to write in the program, the linear search actually is start from the first element to check if 17 equal to 11. If not, I move to the next element. So the same thing, 23, try to compare with 11. If not, I'm moving to the next one. So actually you check each element, are they equal to the matching value or not? If not, we're moving to the end. So the same thing, 11, you find that. But then how about we search for 7? So when you do the 7, actually you see you so fast say, oh no, we don't have 7. But actually what you do is your eyes look at the first element. 17 not equal to 7. So after your eyes look at 17, your brain compares 17 to the 7. So if not, I check next one. I compare 23 equal to 7 or not. If not, I move to the next one. So then you see when we do one by one, then we find out no one match with 7. Then we know 7 is not exist in the array. So I just want you to know, whenever you try to write a program, actually program just try to simulate what the human behavior. Sometimes your behavior is so fast, your brain works so fast, so then your eyes just look at that. But when we write into the code, we need to do the step by step. So that's why here we call the algorithm. Before you write into a source file, to write your job into a source code, before you write into the source code, you need to think about how you want to work on that. That's what we call the algorithm. So when we write the algorithm for the linear search, actually you do is, the first thing, you set found equal to false. Because did you find the value yet? No. So that's why initial value is false. So then we set position equal to -1. The position actually is at the end, I want to know where is the location of the match value. Since we not start working on that yet, we know the array index start from 0. So we set position equal to -1. Then when we start doing the search, we set index equal to 0. In this algorithm, we're using the while loop. So the while loop condition is if index less than the number of data. On the other hand is the size of the array. If the index less than the size of the array and the found is false, that's mean I didn't find the value yet, so I continue to do that. So every time in the while loop, each iteration I try to using the if statement because I try to find the array index. The index starts from 0. So this index value is equal to our searching value or not. If that's true, wonderful. I set found variable flag equal to true. Then earlier we set position, that is where the match data located. So since the index value equal to the searching value, so that's why we assign index equal to the position. So then we end up the if statement. That's if the match data is equal to the list of the index. If not, right, I need to increment my index. Then I go back to the while loop to see the condition is true or not. Then I continue to repeat the if statement until the while loop condition is false. So of course we finish. So then at the end we return the position. So you can see here I have return position. That's me. The algorithm I want to work on is I want to write as a function. So this function, you will pass in an array. You will passing me the array size. You will passing me the value you're searching for. Then after the function finish, I will return the match value position in the array. If the position equal to -1, that means I didn't find the match value. Otherwise, the position is the location of the matching value. So sometimes when we say the algorithm, just the idea how you want to implement in your code. So that's why here we write a linear search function. So like I say, this linear search function, I will pass in the array in the argument, in the function. See, I pass in an integer array. All the time I need a size. Then the value is the value I'm searching for. The return type is integer because I want to return the location of the match value. So that's why we're looking for our algorithm earlier. Our algorithm earlier, we need to set a font equal to false, position equal to -1, the index equal to 0. So that's why I have the initial value set up. So here your index just the subscript of the array. The position, I didn't find the matching value yet, so I set equal to -1. So then I have the bool value, that's the font equal to false. So that's the flag indicates the value was not found yet. So then you see that's our while loop condition. Remember earlier we say, if the index less than the size of the array and font equal to false. So that's why here the not font. So you will see here we have the exclamation mark and the font. So this syntax equal to the same as we check if font equal to false. So that's why you see font, if they are equal to false, we return true, right? So that's why you can see not font. When font equal to false, not false equal to true. So this one actually just a simple way to write font equal to false. So that's all up to you to see how you want to do that. Okay, so then here is our while loop condition. So then we have our if statement. If the value of the index of the array equal to our value we are searching for. So that means we find the value. So we set font equal to true. So the true will make us leave the while loop. Then font equal to true, then the position is equal to the current index. So if this one is true, I do this. If this condition is false, then we just need to increment our index. So then we come back to the while loop. So then the while loop have two situations will be leave the while loop. Either we found the data or the index greater or equal to size. So we leave the while loop. So at the end, we return the position. So we return the position actually show the match value is at where in the array. So that's why we set the default value is position equal to -1. If the position we return from the linear search is -1, that's mean we didn't find the matching value is not found in the array. So that's the linear search function. We pass in the array, we pass in the array size, we pass in the value we're looking for. So then we will return the index value. So that will be the int. So here the example, we implement that in a while loop. Now can you try to see, can you implement this function using a